So in this slide, we are looking at the humoral response, okay? In a primary response, this is the first time that naive B cell is encountering an antigen, okay? The antigen is being picked up by the correct receptor on a B cell, and then proliferation or clonal selection is happening. We now have activated B cells. They either become plasma cells or memory cells. And again, as I told you, those memory cells look identical to the original B lymphocyte because they're going to hang around for a lifetime in order to potentially identify that antigen again in the future. The plasma cells are going to secrete the antibodies, and the antibodies are going to go out and fight off whatever this bad guy is. So in a primary immune response, it can take up to 10 days for antibodies to be produced. And the antibodies are going to peak for a few days, but then they're going to decline. So a person may feel symptoms because it could take a while for the correct B lymphocyte to meet with its antigen, okay? However, after this primary response, you have the memory cell left behind that can very, very quickly, if this little orange antigen or red antigen gets into the body again, there's more of these memory cells hanging out that can easily spot this antigen, and they can, instead of 10 days, they can create an immune response within hours. So within hours, you can start cranking out antibodies, and the amount of plasma cells that end up getting produced, or effector cells they're called, is much greater than in a primary immune response. So then you get a lot more antibodies very, very quickly. You get more memory cells being created, and the person is probably not going to have any symptoms because the B cells were able to so quickly recognize this antigen and create antibodies. This is why we get immunizations right here, in order to prime our immune system with a primary response, so that anytime we come in contact with this antigen, we have a secondary immune response. So in this slide right here, we're looking at the differences between a primary immune response and a secondary immune response. And you can see that the antibodies peak really, really fast in that secondary immune response. It's the reason why we do get vaccinations, is because you get a larger response, and somebody's probably not even going to feel sick. We also talked about the differences between active and passive immunity. So with active immunity, your body is going to make antibodies. And that's a good thing, because if you make antibodies, as we saw on that previous slide here, if you produce antibodies, you're also producing memory cells so that you have immunological memory. So in active immunity, your body is being forced to make antibodies. And that's either going to happen because you get sick or because you get a vaccination that's going to cause your body to fight off an infection. Passive immunity is when you are just given antibodies. So you are just getting right down here. So if you started this process, you never had to go through any of this. So you're not creating any of the memory cells. So when people are sick or breastfeeding infants, they're going to get the effects of passive immunity, but they're not going to get the immunological memory that's associated with active immunity. You should be able to describe active versus passive and then give me a naturally or artificially acquired method of each. So in this slide, we are looking at our antibody classes, and we have 5 antibodies. M-A-D-G-E, MAG, and we call them IGs, which is immunoglobulins, okay? IgM, IgA, IgD, IgG, IgE, okay? So this is what each of them look like. C-M-A-D-G-E. I would like you to read about each of these and understand some of the components of it. So the big one is IgM is the largest. So it's kind of going from largest to smallest down here. IgM is the first antibody that's going to be secreted out in your humors. IgA is going to be found mostly in mucosal surfaces, so things that kind of your internal mucosa, your skin, things of that nature. IgD is always going to be bound to a B lymphocyte. So that would be a B lymphocyte having an IgD antibody associated with it. IgG antibodies are going to be able to cross the placenta barrier. So I say that they can go, so IgG can go across the placenta. And IgE is one that can cause issues. They're really kind of the most minuscule one, and they can actually end up binding with hapten, or an incomplete antigenic substance, and cause allergies for us. So just to review, IgM is the first antibody to be secreted. So if we're testing somebody in the blood and you see they have a lot of IgM, this is probably they're newly fighting some sort of infection. IgA is going to be found in our mucosa secretions. So you think mucosa ends with an A. IgD, is bound to the B lymphocytes. IgG can go across the placenta, and IgE is ew. They can be ew and cause issues with allergies. And last but not least, these are the things that antibodies can do when they fix to an antigen. So here are the antibodies, and then they can fix to an antigen. So we're looking at the little blue antibodies here. So they can cause neutralization, meaning that they can basically bond around the whole outside of a substance, preventing it from doing issue or gaining any access to any of our tissue cells. They can cause agglutination, which means that they can cause stuff to stick together, making it sticky, making it hard to move, so that it's much easier for, say, a phagocyte like a monocyte or macrophage to end up biting onto it. It can cause precipitation, which we know is causing it to fall out of solution. So sometimes antigens can be really small substances, but when antibodies bind to them, they can't just, hide in the blood plasma. They fall out of solution, and again, will end up enhancing something like phagocytosis or complement fixation, leading right here. So this is when complement is going to join with the antibody complex and will end up causing cell lysis. So these are some 4 things, which is neutralization, agglutination, precipitation, and complement fixation that antibodies can cause. So they don't directly go out and kill cells like T lymphocytes do, but they can eventually cause an antigen's demise.